The atmosphere is breaking open right now. What is unfolding across the Gulf Coast and the southern plains is one of the most dangerous multi-hazard setups of the early summer season. We are talking about catastrophic flooding already underway with water rescues on the ground. A potential first-named tropical storm of the 2026 Atlantic hurricane season, threatening to form in the next 48 hours. A multi-day severe weather outbreak still hammering the central plains with tornadoes and baseball-sized hail, and long-range model signals that both the GFS and the European ensemble are now agreeing on, signals that are demanding our attention. Right now, more than 20 million people are under flood watches from central Texas to central Mississippi. The Weather Prediction Center has issued a Level 3 out of 4 flood risk for multiple consecutive days, a streak not seen anywhere in the country since July of last year. There is a lot to unpack tonight, and every piece of this matters. I am Arthur, and you are watching Sky Space Lab. If this is your first time here, subscribe right now. Every day on this channel we pull the latest model data, the latest outlooks from the National Hurricane Center, the Storm Prediction Center, and NOAA's Weather Prediction Center. We do not hype, we do not guess, we follow the data. And today the data is screaming. Let us get into it. Let me start where the immediate danger is highest. Central and south-central Texas, Louisiana, Mississippi. A stalled frontal boundary is locked across the Gulf Coast like a wall, draped from eastern Texas through southern Louisiana and into Mississippi. That boundary is not going anywhere. On the south side of it, warm, moist tropical air from the Gulf is trying to move north. On the north side, weak high pressure is resisting. That stalemate is the worst possible configuration for a flooding event. When a front stalls, every thunderstorm that fires along that boundary parks itself in the same area. It dumps its rain. It weakens. The next storm fires right behind it in the same spot. Meteorologists call this training like freight cars on a railroad track, passing over the same crossing one after another. Each storm is carrying 3 to 5 inches of rainfall per hour. And when you send dozens of those trains over the same soggy ground, rivers flood, storm drains fail, and roads become rivers. Here is the atmospheric physics behind the magnitude of this event. The Weather Prediction Center has posted precipitable water values approaching 2.75 inches along the Texas Gulf Coast. The historical average for this region in June is around 1.8 inches. At 2.75, we are running about 40% above the typical June value. Some preliminary analysis suggests this could be record territory for June in parts of coastal Texas. Precipitable water is the total water vapor in a column of atmosphere above a single point on the ground. More precipitable water means more fuel. More fuel means storms can generate extreme rainfall rates, even if they do not last long over any single spot. And in a training scenario, it does not matter whether each individual storm is brief, because the next one is already forming upstream. Here are the locations most at risk right now: Brownsville, Texas, San Antonio, Houston, Beaumont and Port Arthur along the upper Texas coast, Lake Charles in Louisiana, Baton Rouge, Jackson, Mississippi. Water rescues have already been confirmed in central and south-central Texas as of this update. Flash flooding struck the Waco area overnight, with motorists stranded on southbound Interstate 35 and at least one water rescue confirmed by local officials. The flood threat is not coming. It is here. Here is who needs to watch this the most over the next 48 hours. If you live near any creek, bayou, or river system in eastern Texas or southern Louisiana, do not wait for a warning to act. Flash flooding is among the deadliest forms of severe weather in the United States. It kills more people per year than hurricanes, tornadoes, and lightning. It kills people who assume the water is shallower than it is. It kills people who drive around barricades. 6 inches of fast-moving water can knock an adult off their feet. 2 feet of water can carry away a vehicle. Know your evacuation routes, know your elevation, and if water starts rising near you, move immediately. Do you live in the flood zone across the Texas Gulf Coast? Drop your city in the comments. Tell me what conditions look like on the ground where you are right now. Let me walk you through exactly what the latest model run is showing for rainfall totals, because these numbers need to be stated plainly. The Weather Prediction Center is projecting rainfall totals of 6 to 10 inches across a large swath of the Texas Gulf Coast through Wednesday evening. In the core of the heaviest rainfall bands, likely focused around the Houston metropolitan area, Beaumont and Port Arthur, localized amounts of 12 to 18 inches are possible before this pattern shifts. 18 inches of rain in 3 days is not a forecast I use lightly. That is more rain than some of these cities receive in 4 months. The Trinity River, the San Jacinto River, the Calcasieu River in Louisiana. These waterways are going to respond to upstream rainfall that has already been accumulating for days before the heaviest totals arrive. Flood stage on multiple rivers in this region has either been reached or is imminent. The human geography of this threat matters as much as the meteorology. The Houston metropolitan area alone is home to more than 7 million people. The topography of the Houston region is notoriously flat, with many neighborhoods sitting in the 100-year or even 500-year floodplain. Hurricane Harvey, in 2017, demonstrated what can happen when tropical moisture parks over this region for days. While I'm not drawing a direct comparison to Harvey in terms of intensity, the training storm scenario and the extraordinary precipitable water values create some of the same structural risks. When evacuation orders or shelter-in-place guidance is issued by local officials in this region, follow it immediately. Something else that is worth your attention right now: the soil moisture across eastern Texas and southwestern Louisiana is already elevated from previous rainfall events over the past 2 to 3 weeks. When soil is already saturated, the infiltration rate drops dramatically. Water that would normally soak into the ground instead runs off directly into waterways. This is called runoff acceleration, and it dramatically reduces the amount of rainfall needed to cause flash flooding. In a normal dry soil situation, you might need 3 to 4 inches of rain before significant runoff begins. In a saturated soil situation, even an inch of rainfall can send streams and rivers out of their banks. We're in the saturated soil situation right now across much of this region. Every inch of rain from this event is more dangerous than the raw total suggests. Now, on the atmosphere's larger structure, there is a key dynamical feature I have not yet mentioned: the upper-level low-pressure system that is helping fuel this entire event. An upper-level circulation, carrying atmospheric remnants of Tropical Storm Cristina, is currently positioned over northeastern Mexico. This is not just a moisture pump, it is also a lifting mechanism. When an upper-level low is positioned upstream of a stalled surface front, it creates what meteorologists call differential vorticity advection, a pattern of rising air that is forced upward mechanically by the interaction of the upper-level circulation with the lower atmosphere. That forced lift combines with the extreme moisture and the instability of the warm surface air to create explosive convection. Storms erupt quickly, reach great heights in the atmosphere, and have access to that enormous moisture reservoir. The result is extreme rainfall efficiency. The storms squeeze nearly every drop of moisture out of the atmospheric column and concentrate it in a very small area below. This is the same dynamical setup that produced the Houston flooding events of 2015 and 2016, events that Houston residents still talk about as benchmarks for how bad it can get. The atmosphere today has even more moisture content than either of those events. I want to be careful not to overstate what I know and what I do not know. I do not know exactly which neighborhoods will flood and which will be spared. That depends on storm cell positioning and movement at scales that we cannot resolve in advance. But I can tell you with confidence that the overall threat level for this event is among the highest I have seen in the June climatology for the Texas Gulf Coast. Let me also spend a moment on what happens after the rain event ends, because the flood threat does not disappear when the last storm cell dissipates. Rivers and bayous continue to rise for hours to days after rainfall ends, as water drains from upstream into the main channels. Floodwaters recede slowly, particularly in flat terrain where gravity does very little work in moving the water away. Roads that appeared passable at midnight can be submerged by morning as a river crest moves downstream. This is the secondary flood threat that claims lives even after the weather has moved on. In 2017, some Houston neighborhoods saw waters rise for 3 days after Harvey made landfall. The flooding wave passed downstream slowly. The same process will unfold after this week's event. Now let me connect the plain severe weather story with the Gulf Coast flooding story, because they are not separate events happening by coincidence. They are connected pieces of the same atmospheric pattern. The shortwave trough driving severe weather across the central and northern plains today is the same energy that, at the surface, is helping maintain the pressure gradient and the low-level jet that is pumping moisture out of the Gulf and into the stalled frontal system over Texas. Think of the jet stream as the engine of the entire weather machine and the surface weather as the outputs from that engine. When the jet stream is active, as it is right now with that remarkable 80-knot jet streak at 500 millibars, It spins up severe weather on the northern side and drives moisture flux on the southern side simultaneously. The atmosphere is highly efficient right now. Energy that enters the continental United States from the Pacific is being extracted as violent weather on multiple fronts. Now let me bring in the tropical piece of this story, because this flooding event has a tropical engine. The moisture fueling this entire setup can be traced in significant part to the remnants of Eastern Pacific tropical storm Cristina. Last week, Cristina formed south of Central America in the Eastern Pacific. AccuWeather lead hurricane expert Alex de Silva confirmed that as Cristina moved across Mexico as a tropical rainstorm, it sent a deep plume of tropical moisture northward into Texas. That moisture arrived over the weekend and has been interacting with the stalled front ever since. This kind of cross-basin moisture pipeline, Eastern Pacific tropical energy crossing Central America and reloading the Gulf Coast atmosphere, is a signature pattern of El Nino years, and this is exactly the El Nino setup we are in. The Climate Prediction Center data shows the Nino 3.4 index approaching +1, near the threshold of moderate El Nino status. El Nino, pronounced El Niño, represents the warming of sea surface temperatures in the central and eastern equatorial Pacific. When El Nino strengthens, the subtropical jet stream becomes more powerful across the southern tier of the United States. That jet carries tropical moisture northward. It feeds flooding setups like this one. It also, and we will come back to this, increases wind shear in the Atlantic Basin, which acts to suppress hurricane development there. But here is what the National Hurricane Center updated just hours ago, and it is significant. A trough of low pressure over northeastern Mexico is producing a large and disorganized area of showers and thunderstorms. While the system is currently over land, forecasters are watching for it to drift back out over the northwestern Gulf by late Tuesday into Wednesday. If it finds enough organization over the Gulf waters, it could become the first named tropical storm of the 2026 Atlantic hurricane season. It would be named Arthur. The National Hurricane Center has signaled a medium chance of development in the next 48 to 72-hour window. That probability has been trending upward with each advisory cycle. What does this mean for the flood threat? Let me be very direct. Whether this system becomes Tropical Storm Arthur or stays as a disorganized tropical disturbance, the impact for the coast is nearly identical. The moisture is already there. The rain rates are already dangerous. What a more organized system adds is focus. It can concentrate the heaviest rainfall bands over a narrower corridor. It can push storm surge into coastal bays. It can maintain the flooding threat longer as the low-pressure center creates a prolonged onshore flow. And after landfall or interaction with the coast, the system does not just disappear. By early Thursday, it is expected to get caught in jet stream winds and accelerate northeastward, carrying its moisture into northern Louisiana, Mississippi, Alabama, and Georgia by Friday. This flooding story does not end in Texas. It follows the system. Updated just 1 hour ago, the Weather Prediction Center also confirmed a moderate risk of excessive rainfall for the entire Texas Gulf Coast through Wednesday, as well as for west-central Mississippi through Thursday. Level 3 out of 4 on 4 consecutive days. That has not happened since July of last year anywhere in the country. Now let me take you through the 7-day severe weather picture. Because there are two completely separate weather stories happening simultaneously in the United States right now. The Gulf Coast flooding story and the Central Plains severe weather story. Today is Tuesday, June the 16th. On the central and northern plains, a shortwave trough is digging into the region, interacting with significant instability and a solid wind shear profile. The Storm Prediction Center has highlighted the risk of severe thunderstorms across northeastern South Dakota, central South Dakota near Rapid City, and into western Nebraska. Convective available potential energy, the fuel for thunderstorms, is running between 2,000 and 3,000 joules per kilogram across this region. That supports strong to violent storms. The shear profile supports supercell rotation. Discrete supercells are expected to develop this afternoon. All hazards are on the table, damaging winds gusting to 60 or 70 miles per hour. Very large hail reaching baseball size, around 2.75 inches in diameter, or larger. And a conditional tornado risk that is highest across northeastern South Dakota and into the South Dakota and Nebraska border region, where a discrete supercell or two could produce a significant tornado between the afternoon and early evening hours. After sunset, these storms are expected to consolidate into a line, with the primary threat shifting to damaging winds. That line may hold together through the overnight hours and push into Minnesota by morning. Wednesday, June the 17th. The severe weather threat on the plains continues. The shortwave trough shifts slightly eastward. Northeastern South Dakota, extreme southern Minnesota, and eastern Nebraska see a continued severe weather risk from damaging winds and large hail. Meanwhile, along the Gulf Coast, the flooding continues to intensify as the developing Gulf disturbance adds organization and pumps additional moisture into the stalled front. Thursday, June the 18th, the upper Texas coast and southwest Louisiana remain under the gun for life-threatening flash flooding. Rainfall rates of 3 to 5 inches per hour are still possible in the heaviest bands. Upstream rivers and streams, already running well above normal from days of rain, begin to flood rapidly. The Gulf disturbance, whether tropical or not, accelerates toward Louisiana and Mississippi. Friday, June the 19th, the rain and wind threat shifts northeastward into Mississippi, Alabama, and Georgia. The plains severe weather threat pauses briefly as the shortwave trough exits the region, but a new trough approaching from the Pacific Northwest begins to reload the atmosphere across the Rockies and High Plains. By the end of next week, the severe weather pattern in the plains resets. There is no quiet, extended period in sight. But here is where the story takes a turn, and I want you to understand this part, because it explains why the atmosphere is doing everything I have described and what it means for the rest of your summer. The jet stream pattern driving this entire setup is rooted in something remarkable happening in the Pacific. A Pacific jet extension, one of the strongest June jet streaks I've seen in recent years, is currently overspreading portions of the upper Midwest. The Storm Prediction Center's extended outlooks from Sunday explicitly noted a 500 millibar jet streak greater than 80 knots forecasted to overspread the region by Wednesday evening. By June standards, that is exceptional. 80 knots at 500 millibars in June is a late October number. It is the kind of jet streak that meteorologists mark in red and circle twice. This is what is driving the severe weather severity in the northern plains and what is helping organize the low-pressure systems that keep cycling through. What produced this jet extension? The driver can be traced back in part to typhoon activity in the western Pacific combined with the strengthening El Nino. When large typhoons form near Japan and recurve northeastward, they inject enormous amounts of energy and moisture into the upper-level flow. That energy propagates across the Pacific Ocean in waves, what meteorologists call Rossby waves, and eventually amplifies the jet stream over North America. This is a well-documented teleconnection, and it is playing out right now. The typhoon activity near Japan in recent weeks has been injecting just this kind of energy into the Pacific flow. Now, let me connect this to the big picture summer pattern. Right now, we're in a positive East Pacific oscillation phase. Deep troughs attacking from the west, energy funneling across the continent, relentless severe weather in the plains. That has been the pattern since early spring. The April 17th tornado outbreak produced 86 tornadoes in a single day. Major hail events hammered Kansas and Oklahoma in May. The pattern has been extraordinarily active, but the signal is shifting. Models and the Climate Prediction Center data are pointing toward a trend toward the negative East Pacific oscillation phase as we move through the second half of June. When that phase takes hold, an Alaskan ridge builds to the north. The storm track does not disappear. It slides southward and runs more across the Central Plains, the Midwest, and the Great Lakes, rather than attacking from the northwest. Heat builds dramatically across the western United States. The desert southwest, the Pacific coast, the Rockies, all enter a significant heat dome regime. And the severe weather threat in the Midwest and Great Lakes actually increases in some ways, because the moisture supply from the Gulf stays robust, while cold fronts roll through on a more regular cycle. This is what the Climate Prediction Center is signaling in its extended outlooks. Above normal temperatures across the southern Canadian prairies and the northern tier of the country. Active storm pattern across the central United States. And in the western United States, heat. Sustained. Building heat. The March 2026 heat dome set the template for just how extreme these western heat events have become in the current climate regime. Researchers at major universities called that March event the most anomalous southwestern heat wave in recorded history. Temperatures in Phoenix hit 112 degrees Fahrenheit in mid-March. Denver reached 86. The Boulder National Weather Service noted the city had never recorded a March high above 81 degrees prior to this year. The dynamical mechanism behind that event, a slow-moving, exceptionally strong ridge, trapped over the southwest by back-to-back Kona low events near Hawaii, bears structural similarity to what models are now projecting for midsummer. While the seasonal context is different, the physical mechanism is the same. An Alaskan ridge amplifying, jet stream bifurcating, and exceptional heat building beneath the ridge as sinking air compresses and warms. Most channels are not showing you this part, but it matters for your entire summer. If you are in California, Arizona, Nevada, Utah, Colorado, or the Pacific Northwest, the heat dome scenario is real, and it is in the data. Prepare now. Prepare your home for extended heat. Know where your nearest cooling center is. Understand what heat index values in the 105 to 115 degree range mean for the human body, especially for children, elderly family members, and anyone with cardiovascular or respiratory conditions. And wildfire risk goes up dramatically when heat combines with low humidity and dry vegetation. Fire weather watch season in the West may be just getting started. Now. Before we wrap up, there is one more thing you need to know, and this is the part I've been building toward. Let me take you back to the tropics, not just Tropical Storm Arthur, which may form this week, the longer range picture, the 8 to 12 day window. Multiple ensemble members from both the GFS suite and the European ensemble suite are now showing something in the Gulf or Western Caribbean in the extended range. This is not a situation where one outlier model run is painting an alarming picture. This is a situation where both major modelling systems are developing meaningful ensemble support for a low-pressure system in the Gulf Basin in the 8 to 12 day window. 1 week ago, when models were first hinting at this, the ensemble agreement was minimal. Now we are seeing a different picture. Several members agree on significant low-pressure development. That shift in ensemble support is something I pay close attention to. Here is the environmental context for why this matters. The Saharan air layer, the dry dusty air mass that crosses the Atlantic from Africa and suppresses tropical development, has been thinning over the past week. It is still present over portions of the eastern Atlantic and Caribbean, but the trend is toward less dust as we move through mid to late June. When Saharan dust thins out, tropical waves coming off Africa can develop convection more easily. Sea surface temperatures in the Gulf and Western Caribbean remain well above normal. The waters near the Yucatan Peninsula, the Bay of Campeche, the waters off the Honduran and Nicaraguan coasts, all of these are warmer than average, and the upper-level high-pressure system that is currently slamming the Western Gulf with wind shear is expected to migrate westward into Mexico over the next several days, relieving shear from the central and eastern Gulf in the 10-day time frame. Reduced shear plus warm water plus thinning dust equals improving conditions for tropical development. When GFS and Euro agree on something like this, you pay attention, not as a forecast, not as a warning, but as a signal that deserves daily monitoring. What I am not doing is telling you a hurricane is going to hit the United States. That would be irresponsible at this range. What I'm telling you is that both major modelling systems are trending toward agreement on a tropical threat in the Gulf Basin around the 10-day mark. The environment is becoming more favourable, and people from Corpus Christi to Tampa to Pensacola to New Orleans need to be aware that the tropics are not sleeping. This would be the second potential named system of the season, following Arthur. If Arthur forms this week, the next name on the list is Bertha. After Bertha comes Cristobal. The Atlantic hurricane season runs through November 30th. We are in the early chapters. NOAA's seasonal forecast called for a below-average season, driven by El Nino suppression. But I want you to understand something important about seasonal forecasts. They predict the total number of storms across an entire 6-month season. They tell you nothing about whether your specific area is impacted. A quiet season can still produce one catastrophic landfalling storm. The Gulf waters are warm. The environmental conditions are not uniformly unfavourable, and history shows that Gulf storms can develop rapidly over warm water, with very little warning time for coastal residents. The climatological context for what we are watching in the tropics right now is worth establishing. June is typically the quietest month of the Atlantic hurricane season. The main development region, the stretch of warm Atlantic from the Lesser Antilles westward to the coast of Africa, usually does not become productive until late July or August. June tropical activity, when it does occur, most commonly originates in the Gulf or the Western Caribbean, where warm surface waters and favourable proximity to land-induced moisture sources can compensate for otherwise marginal atmospheric conditions. This is why the Gulf and Western Caribbean are the focus of concern right now, rather than the open Atlantic. sea surface temperatures in the Gulf this June are running well above the long-term average. The waters between the Yucatan Peninsula and the Texas coast are particularly warm. In some areas, the sea surface temperature anomaly is running between 1 and 2 degrees Celsius above the historical average for this time of year. That might not sound like much, but in terms of available energy for tropical cyclone intensification, the difference between a temperature anomaly of 0 and an anomaly of 1.5 degrees Celsius is significant. Warmer water provides more latent heat energy to storms. Storms that develop over anomalously warm water intensify faster and maintain their intensity longer than storms developing over cooler water. If a system does get organized in the Gulf in the 10 to 12-day window, it will be entering a thermal environment that favors development. The wind shear picture in the Gulf is currently unfavorable. The upper-level high-pressure system to the south is imposing significant shear across the western Gulf. But that ridge is expected to migrate westward over the next several days. As it does, it will relieve shear from the central and eastern Gulf. The European ensemble model, which tends to handle medium-range tropical forecasting better than the GFS in many situations, is already showing the shear diminishing in the Gulf in the 10 to 12-day window. This is consistent with what the GFS ensemble is showing independently. When two separate modelling systems reach the same conclusion about environmental conditions through different methodologies, that increases confidence that the signal is real. I want to address something directly, because I have seen other channels handle long-range tropical signals irresponsibly in both directions, either dismissing them entirely or treating them as certain disaster. The responsible approach is this. We have an early season signal in a basin with warm waters and improving atmospheric conditions. We have ensemble agreement building where none existed a week ago. We have a real reason to watch this period closely. What we do not have is a forecast. Track and intensity are not determinable at this range. The signal could verify, meaning a storm could develop and threaten the coast, or the signal could fail to verify, meaning the window closes without organization. Both outcomes are possible. The job of science is not to pick one and commit to it. The job of science is to monitor, update, and communicate uncertainty honestly. That is what I am doing. I will be here every day as this evolves. One final thought before I let you go. Weather awareness is not a one-time event. It is a daily habit, especially during a season like this, when the atmosphere is this active and threats are developing this quickly. Set your weather alerts. Keep this channel in your subscriptions. Share these updates with people who need them. The best time to prepare is before the threat arrives. That is a lesson every flood survivor knows firsthand. I will be back tomorrow with the latest. I promise you that. Watch the tropics every day. Subscribe to National Hurricane Center updates. Have a hurricane preparedness kit ready. Know your evacuation zone. Know your evacuation route. These steps cost nothing today and save everything if a storm materializes. Do not wait until a storm is on the map to start preparing. By that time, the hardware stores are empty, the gas stations have lines around the block, and the evacuation routes are gridlocked. Prepare now when you have time. If this video gave you something you needed today, share it. Share it with someone in Houston watching the flooding in real time right now. Share it with someone in Sioux Falls under the severe weather threat today. Share it with someone in Tampa who may be watching the tropics develop over the next 2 weeks. This information saves lives when it reaches the right people. That is why I build these updates every single day. Tomorrow I will be watching the Gulf disturbance very closely. Tropical storm watches or warnings for the northwestern Gulf Coast could be issued as early as Tuesday evening, and I will have a dedicated update the moment that happens. I will also have the latest on the 10-day tropical threat, the updated severe weather outlook for the plains and Midwest, and the latest on the heat dome building across the west. Come back here for those updates. I will have the data, the models, and the clearest picture I can build for you. Stay weather aware, stay safe out there.